Hi everybody, good evening. So my internet's not working great, so I won't be switching on the video. I'll start sharing my screen. And before we start today's session, is there any question you have from any of the previous sessions or anything from the course in general? No questions? No. All right. Okay. All right, fine. Um, so let me share the screen. Okay. All right. So the presentations is basically just a placeholder. So this is what we have done so far. We've had 4 sessions, and I think you're already all familiar with what we've covered so far. Okay, this has to be Fridays. I believe by now you would have installed R, and depending upon your preference, you might have installed R Studio as well. And this is what it looks like. And then we'll just dive right into um, practicing some commands. And as always, please feel free to unmute yourselves to ask questions or put it in the chat box. And I'm not sure if any more people are joining. So a few comments here and there would be nice so that I know you're following. Okay. All right. So let's begin. Now this, so the in the last class in the last couple of weeks we've talked about different types of data variables. So we have seen how you can store like a single vector, sorry, a single element, and maybe multiple elements in the form of vector, as well as if you want to store some data in terms of that looks like a matrix. Okay. So in all these cases, we've always had a number or a character being stored at the specific place. There was never anything missing. But very often you will have missing data because, for example, if you're recording let's say you're taking a survey where you are asking people to fill up a questionnaire. Very often all of these questions are not compulsory, right? So they may not fill in the answer for some of them because it's optional. So how do you handle that sort of a thing? So suppose the main question is, suppose 10 participants filled some data, but only 8 of them gave an answer for a particular question. And let's say it's a numerical question, so you would like to take an average of all of that. So do you take an average considering that there are 8 elements only? So do you divide the sum by 8 or do you divide it by 10? What do you think is the correct way to go about it? Okay, maybe you're typing, but generally the cases when you're taking an average, you would take it depending on, so if 8 people have filled it, then just 8, right? It doesn't matter that the actual total was 10. You are more interested in those 8, right? Because if you would have divided the whole thing by 10, you would get a much lower number. So that doesn't make sense. So what instead we would like to do is we would like to specifically call that missing number as a missing number or a missing value, have a placeholder for it, but not use that missing place for any calculations. Okay. So the way we'll go about it is, and just for a specific, just like another thing in terms of the matrix is that when you have a matrix, so basically you have a two-dimensional object. All the rows should have all the columns, and all the columns should have all the rows, right? It cannot be that the first row has 3 elements and the second row would just have 2 elements. There would be just 2 known elements, but the third one would still, there would still be a place for it. Okay. All right. So we'll start. So NA or so NA is in caps lock is what is used to is what is used as a placeholder for missing values. And just like normal, let's say if we can define a single value to contain either a number or a missing value. So for example, if I define A as 4 and B as NA, so here you can see on the right that it looks pretty normal. But when so just to be doubly sure, so when we say length of a certain variable, it means how many elements are there in that. So when I say length of A, it means it's 1, and that makes sense. But when I say length of NA, that is also 1. So it means that it's not an empty thing. There's still a place for it. It's just that that place is not, it's not a number. Okay? Or it's not a value for that matter. Neither a number, nor a character, nor anything else. And there is a function. So again, reminding you, function in R is any word or word-like structure which is followed by these curved brackets, right? So there is a function called is.na. If you remember, there were also similar functions like is.numeric, is.character. Just like that, there is a um, function in R which is is.na, which will tell you true or false, that whether or not what you've given inside it contains NAs or not. So very straightforward. If I run this, you can see it says it's false because A is not NA. And if I ask the same thing for B, I get true because B is actually NA. Now, the important thing just a couple of important things to remember. We are not putting a double quotes around it. So what if we do put a double quote around it? So if I write something like this, you can already see that there is a bit of a color difference in all of these cases. So when it's NA, it's shown in pink. And when it's NA in double quotes, it shows here as red. Okay, these absolute numbers, they don't matter. It depends on, so somewhere in the tools, you can select what colors to show up. But the idea is that R is considering all of these differently, right? So this, maybe if I just put this here and for the sake of it, if I write is dot NA on C, and if we run this, so you can already see it's coming up very differently. And then C is not NA because even though you've written capital N, capital A, it's written in double quotes. Okay. All right. So again, just reiterating, NA by itself without any double quotes is an element that R can understand. It is one of the reserved words, and that's a placeholder. So the length of NA is 1 because it's still holding that place. But the function is.na returns a true value for that case only, not for any written in double quotes. And the same thing can be expanded to vectors. So if I have two more vectors, one which is direct, so if I write 3:8, it's going to be all the numbers from 3 to 8, right? As you can see here. And then if I also define a vector using the combine function or the C function here, and I can have a few missing values here and there. So it's also a 6. So in both of those cases, that's a 6 element vector. Okay, so it's a 6 element vector. And here, if I use the function is.na, then it's going to give me as many trues and false as is the number of elements. So it's going to do it element wise. And now when I do is.na on y, then the third element and the fifth element are what's na. So those are going to give me true values and everything else returns me false. Okay. All right. So more people have joined us. So we've just started the session. We've only discussed that NA is a placeholder. So we can have NA directly as a single value variable. So for example, B here, and we can also have NA in one or more elements in a vector. So the length of NA is 1, this is the most important thing to remember out of all of this discussion. So it still holds that place. Okay. Um, Before moving forward, do any of you have any questions? Okay. If not, um, so very often, whenever we are
Sorry.
working, sorry, yes,
Yeah, like length of n is 1, and you have also written length of A.
yes,
Length of A. Yeah.
yes. So A I've
So what
defined
is
here
it?
as 4.
So, okay. Yeah.
So
So
length
length
of
of
A,
A
that
will
is
be
also 4. Sorry, A is 1. So
okay. So
length,
whatever we type in bracket, length of, let's say, whole name, let's say Aditya. So what will be the length? 1 or 5?
so okay. So that is still, so it is, length is the number of elements.
Okay.
So, okay. So in case if I would have written 10 here, the length would still be 1. It's not going to be 2. Length is
Okay.
uh, number of elements. So if here I write length of x, so you can see here that's going to be 6. Likewise, if I
Yeah, I
write,
mean 3 to 8.
yes, 3 to 8, right? So
Okay.
3, 4, 5, 6, 7, 8. So that's 6 elements,
Okay.
right? And
Thank you.
length of y also, since you can see here there are 6 elements here, including NAs, but still there are 6 elements in that thing. It doesn't matter if there are unique elements or if there are digits, multiple digits in it. It is just how many elements are there. The first element, second element, third, fourth, fifth, and sixth, like that.
All
Okay,
all
but
right.
yes, that's
Thank you.
a good question. Yeah. All right. So very often, whenever we are working with vectors, for example, we would like to know which position that is in, right? So when I just said, when we were discussing length, we said number of elements. So that is the number of positions also that are there in that vector, right? We've talked that if you can access those positions using the square brackets, right? So for example, if I write x2, I'm going to get 5. Oh, sorry. I'm going to get 4 here, right? Because the second element here is 4, right? So this is how I'm accessing a position. Now, had this been a very long vector, okay, here I can see that there are 6 elements and the third element and the fifth element are what are NA. But if it was a very long vector and if there were multiple NAs here and there, and if I would have wanted to get the positions where the NA is, I would like to write a command for it. Okay, so we just saw here that when I'm running is.na, I got a I got an output which is also a vector, which also has the same number of elements as my y. And for each position, it's telling me whether that element is na or not, right? So y here has 6 elements. This output here also has 6 elements. And the question I asked was is.na. So which element is na? So it gave me that the third element here, that's true. It gave me fifth element here also as true. But here, how do I find that this is third? Here I had to count, okay, 1 and 2 and 3, and then 4 and 5. But if it was a very long vector, I can't manually count. I would like R to give me those positions 3 and 5 itself. So what I can do is, in addition to writing is.na, I will enclose this in the which function. Okay, so basically this, what I've highlighted here, uh, this output, I am feeding this output to the which function, which false, false, true, false, true, false. And what which function tells me is that at which positions do I have a true value? Do I have true as the answer in which position? Okay, so it's getting the indices or the positions of the trues. Does this make sense? So this is like a nested function. So I'm feeding y to na, to is.na, and the output, which is in the form of trues and false, that I'm feeding to the which function. And which what that does, it gives me where all is true. And that's exactly what I wanted. So if I'm going to run this, I get the output 3 and 5. Okay. If you won't be asking questions, I'm going to assume you understand this. So if, in case it's not clear, just let me know. Okay. Um, Now, another thing that I might want to know is how many NAs are there, right? So out of this answer, okay, so here in this screen, you can see two outputs, okay? Can you tell me through these outputs, how many elements are there which are NAs? 1, 2, 3, 4, 5, 6. How many elements are there which are NAs? So there are two. Perfect, right? Now, how did you find out that it's two? What did you count? Here you counted the number of trues, right? And here you counted the number of elements that are there. In the first case, you counted only how many trues there are, not the whole thing. You did not add 6 here, but you counted only these two things. And in this output also, you can see that there are two outputs, two elements, two positions. So that means that there are two trues. So what we can do now is to get the number of trues. Now, if you remember from, if you've heard of this, we've briefly discussed this in the last class about um, the AND gate and the OR thing, right? Those relational operators. So very often, if you're aware of binary language, true is often called 1 and false is often called 0. Okay, so what you can see here is that this vector of 6 elements can be thought of as having 0, 0, 1, 0, 1, 0. So what I did, if I sum this up, okay, so this is a vector which is basically 0, 0, 1, 0, 1, 0. If I add it up, I'll get 2 here, right? So if I run this, I get 2 as the answer. On the other hand, this output, I can just count how many elements are there in this output. So I can just say length of this output, which I did here. If I run that, I again get 2. So this is an extra bit. It was not covered in the classes as such, but it would just enhance your understanding of what each of this function is doing. If it's not clear, no problem. Let's just go through it one more time. And then, of course, you'll have these commands with you. You can practice. So what we have done, what we are interested in doing is, as an example, we have taken a very short vector, but there would be cases where you might be dealing with long vectors, 1,000 elements, 10,000 elements. You cannot go and count manually where the NAs are and how many NAs are there. So the first question, to find out which positions the NAs are, we can use this function, this combination of functions. So first we do is.na, that gives us a vector of the same length in terms of trues and false. Now from all of this, we can interrogate which position. So basically, ideally, it's going to tell us which positions are true. And when we did that, it gave us position 3 and 5. The second question was, how many NAs are there in all? So through these two outputs, we can either add these up in terms of zeros and ones, which we can do using the sum function, or we can count the number of elements in this output, which we can say it's 1 and 2. So that's 2. So both of this tells us that there are 2 elements in vector y, 2 NA elements in vector y. What do you think these two commands are doing? And do they make any sense at all or not? So basically what I've done is I've jumbled up the sum and length in these two. Would any of you like to try what line number 36 and line number 37 might give us? So just to remind you, this is the output of is.na. So you are taking the length of this thing, and this is which is.na. So you're taking a sum of this. So what's going to be each of these lines here?
8.
Which one is 8?
Sum of which age NA and Y. This one. Line number
Yep.
37.
Perfect. Okay. And what is this?
Length of Y. Okay. It's a 5. 6.
Yes. Okay.
I will do 6.
Perfect. Perfect. Okay. Great. Now, however, these two numbers, they don't really help us with anything, right? 6, well, of course, there are 6 elements to begin with, but what are we finding here? And sum of 3 and 5 doesn't make sense because 3 and 5 are positions. You don't really add up positions, right? So you have to be careful when you are taking a sum of something or length of something. They appear to be very different things, right? Length and sum is different, but sometimes you'll have to use sum and sometimes you'll have to use length. Again, this is not absolutely essential for this week's topic, but it'll just help you understand how we are dealing with it. Okay, so we just talked about is.na, where it's very obvious from the wording that we are finding whether or not something is na. The kind of opposite, if you want to find which cases are not na, right? So here we got this as the output, right? We got the third and fifth position as trues. Now, if we would have wanted the opposite of this, so there are two ways of doing it. You remember this exclamation? I'm not sure if we explicitly discussed it in the last problem solving session, but this exclamation is a not symbol. So wherever you have true, this gives you false. Wherever you have false, it gives you true. So if I run exclamation is.na, then you can see I simply got the opposite answer. So third and fifth element were now false, and then everything else is true. So it just depends on what do you want to call as true, right? It's no hard and fast rule that NAs should always be called as true or the non-NAs should always be called as true. It's up to you. Another cases, another function which is already there in R is called complete dot cases, and that also gives us the same result. So it's basically what the questions are saying, which of these are not NA, which of these are complete. So which is why the output of both these cases is the same. And it's opposite to the output of is.na. Okay, so that's the basic handling of NAs and where the NAs are and how many NAs there are. Now, if you do have NAs, how do you handle those? Okay, so initially I posed the question to you that if there are 10 observations with you, let's say all of them are numbers and two of them are NA, so you're left with 8 numbers. When you want to find the average of those 8 numbers, you sum those 8 numbers and then do you divide it by 8 or do you divide it by 10? So others who have joined this class, what do you think? If there are 8 non-NA numbers, you're taking the average of that entire vector. Do you divide by 8 or do you divide by 10?
Eight.
Sorry, say that again.
8. 8.
8, right? Which makes sense. Perfect. Right? Because the extra 2 things were never there. You did not add anything. So why should you divide it by those? Right? So, but of course, you appreciate that dividing by 10 would give you a different number, right? So I just had this example here. So if instead of NA it was a 0, that still made some sense because 0 is an observation. So in this case, you're dividing 2 and 5, which is 7. So you're dividing 7 by 2. And in the other case, you're dividing 7 by 3 because these are 3 observations or 2 observations. But now when we have NAs, those are not really observations. So very often you would like to discard those and only consider what remains. But again, another question is, what if you never knew that there were NAs? You never checked. So how R handles this is, so again, if you remember, we are talking about these two vectors x and y. X does not have any NA values, y has NA values. So if I directly do a sum of x, it gives me the sum without any error. So that's okay. If I do a mean of x, it gives me that mean also without any error. If I do a sum of y, it will give me NA. If I do a mean of y, that also gives me NA by default. So that R is telling us that, see, as such, there is some missing values here. So you have to instruct me on how do I handle those missing values. I'm not going to directly compute something without like just without your knowledge. So R is telling us that be careful, there are NA values in your data set. So which is a very good thing that it happens. So what we can instruct now, so these two functions, we modify those. So if you remember, again, functions, there's this word, there is a curved bracket, and we've seen in a lot of cases in matrix example and a few more, that you can have multiple arguments, you can have multiple inputs inside this function. Generally, one input can be a very primary input and the others are more subsidiary inputs. So they're just helping you frame, and you'll separate these by commas, right? And they can have names or they may not have names. So again, normally we are just writing sum or mean, but after that, we have another argument which is called na.rm, in short for remove na. And we are doing a true here. So we are saying that you remove the na values and then you handle. So now when I'm doing a sum after removing the na values, I get 5 as the output, which is correct, right? -1, 5, 0, and 3. And when I'm taking mean, it gives me 1.75 because now it's considering only 4 values, right? So 7 divided by 4, that is 1.5. So that's working exactly how we want. So basically what this one-line function did, internally it did 2 steps. First, from this vector, it removed NAs. Another term for removal is omit, right? So it omitted NAs and then it calculated the sum. Or in this case, it removed or omitted the NAs and then it calculated the mean. So we can also do it in a slightly different way. Although here what happened is y was unchanged, right? Y still remains the same. You don't have that. So there's no new vector wherein you have removed NAs. Internally, all of that happened, right? Sometimes you may explicitly want to create a new vector where you don't have these NAs. So you can use this function called na.omit. And then if I run this, you can see that, okay, it's a complicated output, but the main output here is in the first line. So what it did was it actually omitted or it actually removed the NAs. So what I can do is I can run this. So I've saved this output in Y, and you can see here we now have a new vector. And so what we can directly do is we can do sum of y2 or we can do mean of y2, and that would still give us the same answer, right? So again, just reiterating, this step is internally doing the removal of NAs and then calculating. And here we have explicitly removed it, created a new vector, and then we have applied the sum and the mean function on that new vector. Again, both of these methods are absolutely correct. It's up to you which one you prefer. Okay. And this is, again, in case you don't want to create a new vector, you're doing it on the go. So you're feeding one input, it generates an output here itself, and then you feed that into sum. So that's also absolutely the correct way of doing it. So all three ways give you the exact same output. Okay. All right.
Ma'am,
Yes.
sorry, ma'am, um, I have one small doubt here.
Mm-hmm.
Like we are removing NA, like like if you found in a Excel, like we didn't have written anything.
Uh-huh.
So like a space, something like this is a blank one.
Yes.
So can we
Yes.
remove blank one, like a space?
Okay. Good question. So, let's talk about it in another 10 minutes. Okay. Hold on to that question. We'll talk about NA and another thing called null, and then let's see which of those fits your question better. Okay. So we'll just come on to it very quickly. Okay. So until now, we've talked about NAs and vectors. The same thing can happen in matrices also. So just as an example, let's define these three matrices, M, N, O, and let's take a look at what each of these look like. So each of these you can see here, each of these are 2 by 3 matrices. And why do we call them 2 by 3? Because they have 2 rows and 3 columns. So M, N, O. All right, so this is what they're looking like. All right, so the first matrix M, it's an ideal matrix. There are no missing values. In N, what we did, it is 1, 2, 3, NA, NA, 6, but this is filled column wise, right? So 1, 2, and then 3 and 4, and then 5 and 6. That's the order of filling it. And in matrix O, we filled it row wise. So 1, 2, 3 go here, and then NA, NA, 6 go there. Okay. Now, what do you think if I say is dot NA in all the three matrices? What's going to happen here when I write M? How many outputs are going to be there? Like how many, like in the output, what's going to be the output here? What do you think? 0. Okay, so this is not number of NAs, but the question is dot NA. So the output is going to be in terms of true and false. And if you remember when we were doing this with vectors, when we did is dot NA, it gave us as many trues and as many false as the number of elements are there. Yes. So it's going to give us, actually it's going to give us 6 false. Okay. And it was arranged in that particular fashion as well. Right. So likewise, if I do it for N and if we do it for O, it's giving us exactly in that same order. Right. So it's pretty understandable. Now, the second thing which we did there was we wanted to find which element is the one, like what's the index, what's the position of these NAs, right? Now, when it was a vector, there was no problem. You are reading a vector in just one dimension, right? It's 1, 2, 3, 4, 5, 6. Now, matrices also internally, this can be a little confusing, so bear with me. A matrix is always read column wise in R, irrespective of how you filled in that data. So if you remember, the N and the O matrix, the data is exactly the same. It's just that in one of them, we've filled it by row, and in one of them, we've filled it by column, right? However, when you are going to read this, this true and false, when the which function is going to read these trues and false, it's going to read them in form of the column. So what is going to say for N? It's going to say this is false. So 1, then 2, and then 3, and then 4, and then 5, and then 6. So here it's going to say it's 4 and 5 are what are true. And in this O function, in the O matrix, it's going to say 1 and 2 like this. So it's going to say 2 is true, and then 4 is true. So it's going to read this true and false column wise. Okay. Now, this is not the most straightforward example, but this is how it works. Okay. So again, is.na is working normally, right? It's giving you the output in form of a matrix. But which gives you the output in a one-dimensional way. So which element is it? It is. So it's reading the matrix column-wise, irrespective of how you filled that matrix. So you're reading it column-wise, and then you're telling in first case the fourth and fifth elements are what are NAs because they're true. And in the next case, it is the second and the fourth element which give you this true value. Okay. Again, this is an extra example. You're not exactly supposed to know this, but if you do, it'll just help. Okay. All right. Now we come to the next kind of missing data. So we just saw initially that the length of NA, right? If you just write NA somewhere, that length is 1. So there's still a place for it. But if you write null, then it does not have a place. There's no place in there. Okay. So for example, we could define this new vector, right? And you see what happened here. The Z vector. The last value is just not there. Okay, so you're not even interested in keeping a note of that missing value. So again, going back to the example of surveys. So even though, let's say again, 10 people filled the survey and for a particular question, 8 people only answered, you still have that information with you that 2 people did not fill that question in the survey, did not give an answer to that question in that survey. But if instead you would have used null, you would have not kept that information with yourself. Okay, you're just you're excluding that information altogether. So one of you just asked a question about a missing value or a space in Excel, right? So can you repeat your question now?
Yes, ma'am. I was asking ki, like if we didn't put anything
Hmm.
like in an Excel sheet, we don't
Mm-hmm.
have anything. Like
Hmm.
if we are
Hmm.
entering a marks, let's say,
Yes, yes.
and if like somehow we are writing absent, but we are not writing absent. So can we get the details? Yeah,
Okay.
which person is now?
Okay. So let's take an example. Okay, this might take a couple of minutes, but let's take an example. So I'll write, let's say we'll write roll number and we'll write name and we'll write marks. Okay, so let's call it 1, 2, and 3, and we'll call them A, B, and C. And okay, whatever. And let's say marks here we'll write 5 and 9. So, for example, this was a test, and person B did not appear for that exam at all. Is
Yes,
this sort of a setup? Does this make sense? This is
yes,
what you're
yes,
talking about? Okay, fine.
yes.
So I'm going to save this. Uh, where do I save it? No, not this. Where is it? Mm, okay, here I have NPTEL July, and we are in week 5. So I'll just save it as sample. Um, and I'm going to save it as a CSV file. We'll talk about it in more detail, but Excel and R are not very compatible, but CSV and R are very compatible. So I'll just save it as a CSV.csv file. Okay, so I'm going to do that. And now now we want to read that file here. So again, if you remember, we talked initially about something called the working directory. So this is my working directory. So R can currently access this directory, this folder, and that is exactly where I've stored my Excel file also, right? The CSV file. So what I'll do is, let me call, what variable have I not used? Let's call it marks. And I'm going to say read.csv, and in double quotes, I'm just going to start typing and I press tab. So R was already able to search. So it already gave me this. And there are some additional, okay, anyway. CSV header is true. Incomplete. Mm. Okay, so it was not able to find that line because it was missing. Okay, what do we do? It should have read. As is skip check names. Well,
Can you
yeah.
check us file name, or maybe a capital S or what?
Mm-mm-mm. No. So what the okay. Oh, sorry. Wait. So it's just a warning message. It's not an error. Okay. So this is important. It's good it came up. So in the what it said is the warning message is that in this table, whatever we wrote, there's an incomplete line found by um the function. But you can still see the marks are here. So when we open it, this is what it looks like. So it's already NA, right? So automatically it has identified. Now, I'll just like to let you know something that this is not a matrix. It is something called a data frame. We'll come to a data frame in a few more weeks' time. The broad difference between data frame and matrix is that a matrix can have only one type of element, but a data frame can have multiple types of elements. For example, you can see here that roll number is a number, name is character type, and marks are again numbers, right? Anyway, long story short, so although when we read this, it gave us a warning message, we still got our variable defined here. And that missing value was automatically read in um, R as NA. And this is what we wanted, right? Yes?
Yeah.
Okay, perfect. Yeah, sorry for the confusion. I thought it was an error, but okay, it's just a warning, which is great, which is good that R gave us a warning so we can double check. Because sometimes it can happen that you might have mistakenly deleted something here and there, even though you were expecting it to be a completely full data set. Okay, all right. Now we'll move on to the next part of our discussion. So all of these variables that we have defined here, we are not going to use in the upcoming discussion. So we can remove them, right? There are a few ways of removing it. The easiest way if you're working in RStudio is of course this broom right here. So if I click it, it's going to ask, are you sure you want to remove it? But a more R appropriate way of doing it is using RM. And inside I'm going to feed it everything. So if you remember, the ls function is actually list. So list is listing all the variables. So basically what I'm doing is, again, it's a nested function. I'm inputting all the variables into RM. So it's just going to remove everything. So if I run this, everything gets removed. Again, you already have this script, so you can rerun it anytime, but it's no longer in the global environment, so it's just easier to handle. Okay, now we come to the second part, which is if-else statements. Okay, now the most important part here. So we've been talking about vectors, so it might be very inviting to think that if can also handle single values and vectors, but that is not true. If can only the conditional statement, something is true or false, it can only handle one of these at a time. So whatever cases we saw here where we had multiple trues and multiple false, that is not going to work here. It needs to be either a single true or a single false. Okay. So, um, so now we'll talk about the simple case where there is just an if statement. So now when I say if, automatically there's going to be a case where the condition is satisfied or the condition is not satisfied. But we start off with only one case where we're only interested in cases where the condition is actually satisfied. So So up until now, we have talked about two brackets, right? This curved bracket, which we are mostly using, which we are almost always using when we are talking about these functions, the commands, not function, commands or yeah, commands in R. Also, when we are doing any mathematical operation, so we are always using multiple brackets. That's always going to be curved brackets. And we've talked about the square bracket whenever we are interested in accessing a certain position or indices. Now we get introduced to the third bracket, which are these curly braces or flower brackets, whatever you want to call them. This often is said that these brackets are defining chunks. Okay, so chunks, that's a very programming language term. So it's a group of commands, group of statements that all generally they are all executed or they are all run together. If one is run, all of them are run alongside. Whatever you're writing within this uh, bracket. And of course, as always, you have to have a closing and opening bracket. And it's just a good practice. Again, it's a matter of preference, but it's a good practice that wherever you've written if, on the same line, you'll start the curved bracket. So let me write this again so you'll see how it's getting typed. So I'm typing if, and you can already see that as soon as I've typed if, it changes color. So R is able to recognize that it's a reserved word. And then I'm putting the curved bracket, and then I'm putting the condition a less than 5. I go out of the bracket and I put the curly bracket. So you can already see that I have these opening and close both coming up. Now I'll press enter here. So what you can see when I press enter is that my cursor actually came a little bit inside. It did not start from the very starting, but instead it started a few indents to the right. Okay. So it's just for ease of um, understanding that whatever I'm writing inside is actually inside this if. It's not a part of my main everything else that I'm executing. It's within a certain chunk. Okay. So and then here I can just write print and let me say yes. So it's the same thing that I've typed here. Okay. Now how it's going to get executed? So again, one element, it gets executed just once. There's not no multiple things happening. That multiple things is something called the loop, which we'll talk about a lot later. Currently, we are just saying one element, one output. Okay. So what we are going to do here is we'll take two cases. Case one, when a is equal to 4. So I'm going to run this. A is 4. Now, if I just run this very inside thing here, a less than 5, what is it going to give me? What's the output of a less than 5? True. Yes.
Yes.
All right. So the so we had this comment here, right? That the value inside whatever this is, it must be either true or false. So yes, it is true. If it is true, then this chunk, this set of bracket is the sort of, you can imagine there's an imaginary cursor. So it goes inside this and it comes up here and then it executes this line. So if I put my cursor here, what I can do, I can select the whole thing. And if I run this, it gives me the output yes. We'll take the second case. Now, if instead a was 9, again, I select the whole thing. Now, since this statement is going to be false, I do not get any output. So take a look at this case here, right? When a was 5, when I executed this, I got yes as the output. But when I executed this as after when it was, when a was 4, and now when a is 9, when I executed it, I got no output. Because I did not tell it what to do if it was false. I just told it what to do if it was true. So now let's add up one more thing. So what we'll do is, we just wrote this much in the previous line. We'll, after this line, this space is again, it's not super needed. It's a matter of your convenience. So just after, wherever we are finishing this bracket, we'll write else. And we'll start another bracket there. And then we'll tell it what to do if it was false. So if this statement is true, if whatever we are writing inside is true, you execute this line. But if it is not true, you execute a different line. Again, let's take the same cases. Let's take A is 4. Now I need to execute the whole thing. I select the whole thing and I get yes, which is correct. Now, if I write A is 9, and now if I execute the whole thing, I get no, right? So A is 9, I execute the whole, no, sorry, here. A is 4, I execute this whole thing, I get yes. When A is 9, I execute the whole thing, I get no. So is it understandable?
Yes, ma'am.
Yes. All right. Perfect. Good. Okay. So again, just to stress this point again, if and if else, they're not designed to handle vectors. At a time, they can only handle one value. So if we do try to give it a vector, so let's say if I give it a vector now, it's going to give me this error. That error in this, the condition. So whatever I'm writing inside, if that's actually called the condition. Maybe here I can write this is condition. So if this condition has more than one true or false, then it's going to give an error. The condition has length greater than 1. Because this statement, it has length greater than 1, right? So which is why it's not going to work. Okay. Now, there are some more complex ways of doing it. I'll just walk you through this a bit. We don't have to go into a lot of detail, but let's take, so here we had just written a less than 5 or a greater than 5, like that. Now we can also have something a little more complicated. Remember in the last class, we talked about statements like these. So again, this is still a single true or a single false. So we'll take the first case, D is 8. Can you tell me what is the output of D greater than 5?
True.
So
True.
that's true. And D less than equal to 9?
False.
That's also true. 8. Yes. Okay. And when I do a true and true, what do I get?
False.
No. No, true and true
True.
is
True. True.
true.
True. True.
Okay.
True. True.
Okay. This thing, please practice this out. So what you can simply just do, take cases like this. So I'm not executing these lines, but just to practice, you can do, okay, let me show you something nice.
Ma'am, it's like a Boolean operator, right?
Yes,
True.
yes,
True.
it's
True.
yes, yes, exactly. It's the same thing. And or and gate or gate,
Yeah.
like
Yeah.
that. So just let me show you something. Just it's going to just help you. I'm just going to do some essays. So these are the 4 cases you should definitely know about. If I want to put a comment, like if I want to run all of them as a if I want to convert all of them in a comment, I'll do Control Shift C. So I don't need to type the hash again and again. And if I want to remove the comment, I'll select them all. I'll do a Control Shift C again, and the comment goes. Okay. So why we did this? You can execute each of these lines and you can see what you get. You can see in the console below that it's being run. So just practice this out for your reference, and so it's going to get clear. Okay, so coming back to what we were practicing. So this is true. This is also true. So true and true, they give us true. In short, this condition is true. So the first chunk is going to get executed. Okay, the chunk after if. Now the chunk is a little bit, there's a lot of thing happening here. So let's try and execute the whole thing. So what happened here was this whole thing got executed and all the lines. So inside I wrote print double quotes q, so it printed double quotes q. Then I said call a as 9 and then print a. So it printed 9 also. And then I said print yes in double quotes, so it printed yes also. Right? So it did all the statements that are there in this chunk. Now, there was another case when d is 0. So now can you tell me what is the inside of this? So d greater than 5 and d less than equal to 9. What does the whole statement give us?
False.
Yes, correct. Because this gives us false, this gives us true. So true and false gives us false. Okay, so the whole thing is false here. So when I run this whole thing, I now only get no as the output because the else command gets run. Okay, easy. Now, this is the most common way in which you will see if else statements, especially because very often you would have it a complicated statement like this. When a condition is satisfied, you'll execute a lot of commands. Sometimes even when it's false, then also you might have a lot of commands. So it's easier to write that in multiple lines rather than stuff everything up in a single line. But sometimes you might want to um, stuff things in a single line. So there is this option of if else. Now the way if else works, again, the ordering is very, very similar. What did I do here? Okay. So take the first line for an example. So it's a very similar case to what we just saw above. Here so there are three inputs you give to this command. The first thing is that condition. The second input is what to do, what to print. Basically, what to print when it's true. And the third argument is what to print when you have when it's false. Okay. So again, if d was 0 here, and this is what we were doing, then it gives us false as it gives us no as the output, because we just saw that this is false, this is true, so the whole thing is false. Okay. Again, you remember that the and is generally used to when you're working with vectors. But again, here, since you just have a single element, it doesn't matter which one you're using. Now, here, the major difference in these two examples was here we said print. Here we did not say anything like print, but it still got printed. So what if you explicitly write print here? Now, this was something we discovered after brainstorming a little bit. But anyway, so here when I'm running it as print, it's giving me output twice. Okay. Now it was really a little complicated to see what was happening. So basically print is giving us an output twice. It's putting the inside thing also and then the print thing itself. So the best way to go about it is to not use print inside if else. Just write what you want to print directly, not print. And another thing about this if else command itself is that it can handle multiple trues and false. So it can handle vectors. So for example, if I define a vector, yes.
Sorry to interrupt. Actually, the 153 line,
Uh-huh.
if else d greater than 5 and d less than or equal to 9, it's
Uh-huh.
a false statement, right?
Yes.
Based on
Yes.
this. So, like if you are writing print yes and print, I'm just giving a try. So, like our like according to this condition, our print no is correct, right?
Mm-hmm.
But we are writing two, so it might be happen because we are writing two prints, that's why given no or what? I don't know.
Say that again.
Like our statement is false here. So
Hmm.
based on the statement, if else, like else statement will print.
Yes,
So
correct.
no will come in our output, but we are giving two print. So maybe they like considering two times of no. And it's not considering yes. I don't know. It's happening
Hmm.
with uh,
I'm not very sure on this. So the only conclusion I was able to draw so far is that um to not use print. But again, I'm not 100% sure on how this is working.
I will try to find out like
Yes, you can definitely give it a try, and you can let us know either in the next class or in the question answer
yes,
forum. Yes, sure.
yeah.
Yeah, so things like this can be a little complicated. Sometimes it's difficult to understand what's happening. So, but yes, it's just good to know that this might happen. So you can, whenever, especially when you're working for your own work, you can decide if you want to go for the if else or the conventional if and else, this format. Okay. So the last thing from the, no, not the last thing. This from the if else command is that it can handle vectors. So when I do something like this, it's going to give me multiple trues and false, right? So now what happened here is it gave me as many yeses and nos uh, as were these conditions here, right? So again, it's a little more useful if you actually have to work with vectors around an if else statement, right? The conventional if and else cannot handle that. And again, um, so yes, again, um, so here also what this is doing is it's printing the printing this and this as well, because both of these are a part of um at some point of time they're both getting executed, and then the actual if else output which you're interested in, that also gets executed. So again, I think this might give you a little idea on what's happening when we are writing print. But in short, I would still advise you to not write print inside the if else statement. Okay. Okay. All right. Now, just a little one final thing from this part about what happens when you're using a single and or a double and, or to be more accurate, this is an ampersand symbol. So what happens when you're using single or multiple? I mean single or double. Okay. So we have the vector A, which is 1 to 10. We have a vector B, which is also 10 elements, but different 10 elements. So now let's see what do we get here. So A greater than 6, we know what the simple output is going to be, right? So the later half numbers are giving us true. And if I say B is less than 20, then everything except the last number, which is 21, that is giving us true in this case. Okay. Now if I write and, just the basic and, I'm going to get as many trues and false, right? So false and true. This is also false and true, so on. And then this becomes true, 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 and this is also true, true. Fine. So this is understandable how this came up. Now, if I write and, so it is giving me some sort of an error. Okay. Uh, because why is it giving this error here? Wait. It should have given me at least one output. Mm. Mm, okay, this is not how it was supposed to happen. Gave me a warning the last time it was working. Okay, I'm so sorry this is not working right now. So normally what the double and thing does, um, it it should only work for, so anyway, long story short, it's always better to use the single ampersand, the simple thing, because it works for both vectors and single elements. The and typically only considers the first value. So in short, you should always use the single ampersand, not the double ampersand. But this I've not been able to make it work today. I don't know what happened. I'll have to see this again.
Yeah,
But
ma'am, like first value means like a greater than 6, that will count 6 only.
no, first value means 1 and 3 only.
All right.
Yeah.
Okay.
Because and is only supposed to work with um single elements.
Yeah.
It and is obviously combining left and right? So you have to have these two things here and there, but they themselves should just have one value each. But again, this is again not super important. So it's easy and it's best when you have a single ampersand only. And again, a single or also here rather than a double thing. So this setup will always work for you. That is tried and tested.
All right.
Okay. All right. And I think now we've just reached to the final bit. Um, Again, we've just talked about these conditions here. Um, okay. Mm. Okay. So what we can type here is, generally if I say if a less than 3, right? Now, or maybe I'll just write a less than 4. Now, if a is less than certain number, I mean a is following a certain condition, it does not tell us whether b follows something or not, right? So what I can write instead, I can write in terms of if, let's say b greater than equal to 6, I can write something here, print, let's say case 1. I'll write else. Okay, I'll set up something and then I'll ask you to tell me what is happening everywhere. Mm, okay, now take a look at this case. Okay, take a look at this entire setup. Now it looks complicated, right? But we just wrote it so quickly, so it's not very complicated. Don't worry. This is an example of a nested if-else. Nested basically means one within the other. So what is happening here is, we first talk about this bracket. You can see it's highlighted here. So we'll talk about this chunk first. Now we go into this chunk only if a is less than equal to 4. If a is less than equal, sorry, if it's less than 4. Now if a is less than 4, our question arises, what is the condition with b? Now b may be equal to, maybe greater than equal to 6, or b may not be equal to may not be greater than equal to 6. So can you tell me, when would I get case 1, case 2, case 3, case 4 printed? What would be the conditions of A and B at that time when I get each of these cases as the output?
Like if a less than 4, so here we can mention
Let's say A is
b.
equal to 2. If A is equal to 2,
Case 2.
yes, and B is
Case 2.
equal to, sorry, case 2, yes.
Yeah, case 2 will print if we run this one.
Okay. Okay, no. Okay, so A is 3, B is 10. A is less than, let's say 4, more than 6. So in this case, okay, tell me in this case, which is what is going to get printed. We'll walk through it one by one again. But so let's go step by step. So we first, our cursor is here. So we'll read if A is less than 4. So A is 3. So that is true. So we get inside this chunk. We forget this chunk entirely. The else chunk is forgotten. We are straight away inside this chunk. Now, when we are inside this chunk, our cursor comes here and it takes the second case. It says if B is greater than equal to 6. So that is true, right? Because B is 10. So it is greater than equal to 6. So we get inside this chunk, right? This chunk right here, and it prints case 1. Does this make sense?
Yes, ma'am.
Okay. Now, one more example. If instead I had 9 here, if A was 9 and B was 10, which case would get printed? There are 4 options for you.
Case
Which one
4.
gets printed? Case 4,
No,
are you
no.
sure?
Ma'am, case 3.
Case
Case
3.
3.
Case 3,
Yeah.
yes. Because this gets
First
false.
one. Yeah.
So we don't go here, we directly go here. Sorry, we go here. And then for B, that is true. So we go inside this case. Now, if and else, these are exclusive statements. If you go in the if thing, you won't go into its else. If you don't go into if, you automatically go into else. Okay. All right. So so that's easy, right? Now, there is one more way of writing the same thing. Okay, I've taken okay, I think I had it written anyway here. Okay, let's write it again. Okay, so here what we wrote was, here we had two main if else statements, and inside each of the if and else we had another if else. So we had a total of 3 if else, right? 3 if else pairs. There's one more way in which we can write it. So if I write if we had A less than 4 and B greater than equal to 6. Let's say that's the first case. So we'll just write print case 1, right? This thing, it's the same thing, right? A less than 4 and B greater than equal to 6. Now what I'll do is, I'll write else and I'll write if again. So what I'll do here is that I'm going to write A less than 4 and B less than 6. Oopsies, this. So I kept the first thing consistent, but did the opposite for B. And then, so here I'll automatically go into case 2. Now just bear with me for another minute. If that is also not true, I'll write if again. And then I'll do opposite for case A. If I'll write A greater than equal to 4. And then I'll keep the B consistent maybe. So I'll write B greater than equal to 6. So here I'll write print case 3. And finally I'll write else. And there's basically just one case. So I don't need to write if again. I can write if, but I don't need to. So I'll just write print case 4. Now, see, the first thing is you'll get the same output as you got in the previous one. But it took us a lot more time to write this thing because you had to be careful that the opposite of less is actually greater than equal to. The opposite of greater than equal to is less. So it's more complicated. This one, even though it's taking up more lines, it's more intuitive to write. Anyway, so the idea behind this exercise was, and again, this is the same thing. There are two ways in which you can have if else written in a more complicated way. You can have in the nested form, or you can have consecutive if else statements that cover the entire four cases. Again, it's your wish which of the two alternatives you like more. There's scope for error in both of them, so you have to be careful when you're writing either case. But it can help depending on what sort of a work you're using it for. This sort of a setup can be really helpful. Okay. So this is just the final command here, that, I mean, the concluding remark, that this final else in this case, it's just ensuring that all the remaining options are taken care of. Okay, I have a question for you. It's just a practice thing. So we have discussed so many conditional statements, right? If, the if else, nested if else, and this if else consecutively. So the task is, using any of those forms, try and see if you can find if you input a year. Okay, let's say you input A as the year, if a given year is a leap year or not. So the important things you need to remember about a leap year is that, first case, if it's not divisible by 4, then so definitely it's not a leap year. But if it is divisible by 4 and it's not the end of a century, right? That 100, 200, then it's also a leap year. But it's also, if it's the end of a century, if it's like 2100, then it should be divisible by 400. Only then it's called a leap year, right? So 2100 will not be a leap year. Okay? 2200 is not a leap year. 2300 is not a leap year. But 2400 is. 2000 is. Again, this is not absolutely essential for you to do. But if you're able to make this if else statement, you'll have a good grasp on this. So you can practice this now or later. I'm not going to ask you the answer, but we can definitely discuss this in one of the subsequent classes if you're interested. But this is just for your practice. Okay. Now the final thing to be discussed for today's session is two commands, switch and which. Now, which we have already seen previously, right? So we will just walk through that quickly and then we'll come to switch here. So which is used to get you the positions wherever a certain condition is satisfied or wherever you have truths. Okay, so again, we'll take two examples, one of a vector and one of a matrix. So the vector is your vector A, which is 1 to 10. And your matrix is this matrix M, which is these 6, like a 2 by 3 matrix. So if I say A is equal to 7, I get the 7th position as true. So if I write which, I get 7 as the output. Okay, I think this is a bad example. Let me do it so that it's not in the same order. Yep. So here it gives me, somewhere it gives me a true, and then it gives me the position. So the 4th element here, that is true. That's what we have seen previously also. And when we write matrix, sorry, M is equal to 30. So wherever there was 30, it's going to give us true there, right? Here it was this position, right? The first row, second column. So we just saw initially in today's class that when I write this, it shows me 3. That is the third element of the matrix. What does the third element of a matrix mean, right? So it means that when you're reading the matrix column-wise, doesn't matter whether you filled the matrix row-wise or column-wise. A matrix is read column-wise by R. So when you're reading it column-wise, then the third element is 30. Now, there is another argument in the which function which can sometimes be a little helpful. So that's called arr.ind, which is in short for array index. When I write true for array index, it gives me this output. It shows me row 1 call 2. Now that is a little more understandable, right? Row 1 call 2. Again, this is just some extra information. So a very common aspect of handling things in R, or for that matter in any programming language, is that there are a lot of options available. They may not be very, very evident when you're first using that command, but depending on what sort of a usage you want, you'll have to search a bit around it, and then you'll be able to get that answer. Okay, there's a little bit of searching you might have to do. Okay, there are a few more examples here. So if you remember, we had this remainder function, right? So when you do a remainder, again, this is just another example. When you do a remainder with 8 for all the elements, this is what you get. Now, if you're interested in finding out which of the remainders is 4, you can use this command, right? So m percent 8 equal to 4. So it's going to give me this and this position, right? These were 4 here. And now when you want to find out which positions are these, it's just going to give me 2 and 6. So again, the same thing that when you're reading the matrix column wise, the second and the sixth position are what satisfy this case. But then you can always do it array end is true. So it gives me that the second row first column, which is, where is it? Second row first column and second row third column. This is where my answers are. And this is also the same thing. Another example. And finally, moving to the switch command. So there are two ways in which the switch command works. When it returns the value at a given index. So the first argument is going to be a number, and the second argument is going to be not just the second argument, but all the subsequent arguments are going to be treated like a vector. Now, if I write switch 2 and everything else I'm writing like days of the week. So it gives me, when I say 2, it gives me Tuesday. Easy, simple, second element. But now, if I have 7 elements only, and if I write 8, what happens? It says me, it just doesn't give me any output. So I have this command here, no default, no output. Okay, there is a way to write a default in this as well. What was the way to write the default? Okay, I don't think there is a default, is there? I don't know. Okay, maybe there's no default. Okay, so there's no default, so there's no output. I mean, there's nothing happening here. Now, if here what we did was we fed it multiple elements, right? Each of them. So this is element 1, this is element 2, and so on. Now, what if I just had one large element? What if I write 2 here? Or what if I write 1 here? Is all of this going to be considered as one element, or would it be split into these 7 elements? What do you think?
It's a vector, ma'am.
It's a vector, yes. So what do you think would be the answer of line 218 and 219?
Same, I think Tuesday only.
Okay. So what happened here was, so R does not split. So for R, this is one value, this is one value, and so on, right? Each of this is a single value. Likewise, this whole thing is also a single value here. Okay. So if I would have written another value here, let's say A, B, C, whatever, X, Y, Z. And then if I would run this, it would give me ABC as the output, because this whole thing is the first element now. This is element 1, element 2, element 3. Okay. And if I have just one written here, then the first element comes up, which is that whole vector. Okay. And so this is one way in which switch works. And the other way, it's like a named list. So here I'm writing, here I had numbers as my first element. Here I have a certain name, and that name is going to match one of these names here. So the way named lists work is that you have an is equal to, before the is equal to is the name, and after the is equal to you have a value. Okay, so in this case, day 1 is the name for the value Monday. Likewise, day 2 is the name for the value Tuesday, and so on. And you can always have some places where you don't have a name, right? So there is no name here, right? So if I write this, it said that, okay, extract day 4. So this is day 4. What was the value of day 4? That's Thursday. So it gave me Thursday as the output. But now in this case, I'm writing day 8, but day 8 is not there. However, when we are working with names here, the value without a name is considered to be a default value. Okay, again, this is a little complicated, but can't help it. This is how it works. You'll get more familiar with it if you use it more. So value without a name is considered as default. In that case, when we were only working with indices, there was no way to define a default. But now when you're working with a named list or a named setup, then the variable without a name is considered to be a default. Okay, so when we write day 8, since day 8 was not present as any of the dates, any of the names, so we went to the default value. All right, so that is what we had for today. It's a little complicated, so I would highly advise you to go back and try a few things. It will definitely make things clearer. Just towards the end, I have, I think, 2 or 3 questions for your practice. Yeah, I think I just have, okay, I just have 2 questions for your practice. Okay, because a lot of things we did cover when we were initially, when we've throughout the session. So it's not explicitly here as your question answer, but there are 2 questions finally. So what do you think is the correct way to calculate the mean of this vector? And there could be more than one correct answer for this. So what do you all think?
A and B.
No, check, try again.
Mhm.
One of those is correct, and one of
B and C. B and C.
correct. Yes, B and C.
Why not
So,
A mention omit?
in the mean function, first value is obviously the vector. The second value is an argument in that function itself. So that's a fixed thing. So that is going to be na.rm. Na.omit is a function in itself. So that is how you write
Okay.
that function. Na.rm is an argument. Na.omit is a function.
All right.
All right. Yes. So again, this question is meant to confuse you, but good try. All right. And just one of these other questions. Again, this is very simple. You should be able to do it, but let's give it a try. So this is just to reiterate that the if else this setup can handle vectors. So the vector here, that's 12, 4, 16, 8, 25, and 14. So if x is less than 10, we execute the first part. But if it is greater than or equal to 10, then we execute the second part. So
No,
we'll
option
first,
D.
okay, that was very quick. So let me just walk everybody else through the whole thing. But I think that should be correct. So, so if x is less than 10, we add 2. So this is less than 10. This is less than 10. This is less than 10. That's it. And Then when x is greater than 10, greater than or equal to 10, we multiply it by 2. So this gets multiplied by 2. This gets multiplied by 2. This gets multiplied by 2. And this gets multiplied by 2. Right? So yes. So option D is the correct answer. All right. So that's pretty much what we had. Do you have any? Oh, by the way, one more. There's one more thing remaining. I will still have to double check with the other TAs, but if we have time, if you would go to the assignment for this week, there are a couple of questions on something called functions. Now that was not explained. I think it's an error. So I will definitely try and get back and see if those questions are not going to be evaluated this time, because functions were not discussed this week, right?
Yes.
Okay. So I think it should not be evaluated, but I would still just give me 5 minutes and I'll give you a crash course on what functions are. So what we have done so far here, very often when we wrote this whole thing, to do it with different values of a and b, we had to change the values of a and b each time, right? So we wrote like different values here every time. So there are these inbuilt functions in R that we've been using, right? This is a function in R. Everything that we have seen so far, which has this bracket, everything is a function in R. You can define your own functions. We'll just call it, let's say I'm calling it custom func, and I'll write function. The function can accept one or two inputs. Let's say I'll say it accepts one input. I'll call it x. Again, I'll put a chunk here, so that curly bracket, and I'll write so I'll say sum x comma 6 comma 7, print x, print x minus 3. Okay. Now what I'll do, now I'm going to execute this function. So I'm pressing enter, control enter. And you see here in the environment now functions have also come up. Now what I can do, I'll just write custom func and I'll put in whatever value I want. Let's say 3. When I enter 3, okay, so wait, this did not get, okay, I'm going to run it again. So now you see what happened here. It executed this line. So 3 plus 6 plus 7, so that's 16. It executed 3 itself. It executed 3 minus 3 also. I can run it again. I can say custom func 7, and it again runs for whatever value I fed it. Okay. Likewise, I can have another function. Let me say it inputs 2 values. And now I am going to execute that. Let's say I'll say 2 comma 9. Oopsies. Sorry. Okay. So again, what I did was my function accepts 2 inputs, x and y. So 2 is going to be called as x, 9 is going to be called as y. And then I execute each of them considering x is 2 and y is 9. And I get the respective outputs. Again, I'll ask the TAs to remove that question because it was not taught in this week. But functions are pretty simple. So you can still try to attempt the question. It's no harm. I think functions would be explained in the next week's lectures anyway. But again, it's just because we had a little time before this class ends. It's just worth it. But again, we'll discuss this in more detail when it actually comes. All right. Any questions?
Yes.
Okay. All right. So that's about it for this week. Thank you everybody for joining. And so again, the assignment is to be submitted on coming Wednesday, that's 28th of August. And our next session for week 6 could be on next Friday, that's 30th of August. Okay, all right. Thanks for joining. I'll see you all next week then. Bye-bye. Good night. Thank you.